Section 3.5, Implicit Differentiation, Part 2. In this video, we will review inverse trigonometric functions. Okay, so here's our unit circle. Let me start labeling some of the angles and points on the unit circle. So our quadrant angles are 0, pi over 2 at the top, pi, and 3 pi over 2 at the bottom. The quarter marks, I'll do those next. So pi over 4. So this is 1 pi over 4. 2 pi over 4 is at the top, but it's already marked. So 3 pi over 4 is here in the second quadrant. 4 pi over 4 is already marked. That's the same thing as pi. 5 pi over 4 is in the third quadrant. 6 pi over 4 is already marked. 7 pi over 4 is in quadrant 4, and then 8 pi over 4, or 2 pi, is here with 0. Okay, now I'll do the same thing, but I'm going to count by pi over 6. So this first angle is 1 pi over 6. Next we'd have 2 pi over 6, which reduces. 3 pi over 6, which also reduces at the top. 4 pi over 6 reduces to 2 pi over 3. So we're at 4 pi over 6. Next is 5 pi over 6. 6 pi over 6 we have 7 pi over 6. 8 pi over 6 reduces. 9 pi over 6 we have 10 pi over 6 reduces, and finally 11 pi over 6. Okay, so I went around the unit circle, first marking off the quadrant angles, then I chose the quarter mark, so pi over 4, 3 pi over 4, 5, and 7 pi over 4, and then I went around counting by pi over 6s and reducing any angles that could be reduced. Okay, next for the angles, next for the values of sine and cosine. So on our unit circle, so the origin is at the center. To the right, that's the coordinate 1, 0. So at the top, we have 0, 1. To the left is -1, 0, and at the bottom, 0, -1. So remember, cosine is first, so it's cosine theta, sine theta for our xy values. Okay, so this is bringing us to the first question here. What is sine of pi over 6? I'm only going to mark things off in the first quadrant for now. So notice we were at 1, so this is going to decrease to 3 pi over 2. Sticking with cosine, so I have 3 pi over 2, I have rad 3 over 2, rad 2 over 2, rad 1 over 2 is just 1/2, and then rad 0 over 2 is just 0. So that pattern continues, right? So sine of 0 was 0. Okay, so now I'm going to fill in the sine coordinates, the second guy here. So we start at 1/2, rad 2 over 2, rad 3 over 2, rad 4 over 2 reduces to 1, right? So that same pattern continues. Okay, so sine of pi over 6 must equal 1/2. Sine of 5 pi over 6. So now I'm looking over here in the third quadrant, okay? And this is going to be, I'm going to look at pi over 4, okay? So the values are going to be the same at 5 pi over, oh sorry, not 5 pi over 4, I want 5 pi over 6. So sorry about that. We're here, 5 pi over 6 is here in the second quadrant. Okay, so 5 pi over 6 is, on the circle, it should be symmetric to pi over 6, which is here in the first quadrant, okay? So when I label the values for sine and cosine, I still need rad 3 over 2 and 1/2 for cosine and sine, but since I've gone to the left to get to the second quadrant, my cosine value is negative, and I still go up a 1/2 unit, so the sine value remains positive. Okay, so at sine of 5 pi over 6, the sine value is still 1/2. Okay, next we do want 5 pi over 4, so cosine of 5 pi over 4. Okay, so now we are down here in the third quadrant. I'm going to look at the angle pi over 4. Okay, so we have rad 2 over 2, However, this time I am now in the third quadrant, so both the x value and the y value are negative in the third quadrant. Okay, so cosine of 5 pi over 4 would be negative rad 2 over 2. And then we have tangent of 5 pi over 4. Okay, so tangent is sine over cosine. These values are the same, so its ratio will equal 1. Okay. So now we want to look at inverse trig functions. Okay, so here is a completed unit circle. Okay, so notice that the first quadrant is what I had filled in. If you were taking a test, what I tell my students is to just label what you need to. So if you want to start with the first quadrant, label quickly everything in the first quadrant, and then just label the other angles as you need them, okay, because you won't need the entire unit circle for your exam. Okay, so we want inverse sine of 1/2. So we have to remember that for our inverse trig functions, we want to remember where to look on the unit circle. So for sine and tangent, bottom to top, okay? So we're going from negative pi over 2 to positive pi over 2. Okay, so we're in the fourth quadrant, and even though these are marked as 5 pi over 3, 7 pi over 4, etc., we want to think of those as negative pi over 6, negative pi over 4, and negative pi over 3. Okay, and then this guy as well, negative pi over 2. Okay, so sine and tangent, bottom to top. Cosine, I call it a windshield wiper. Okay, we're going to go from right to left, right? So if you wave your arm that direction, it looks a little bit like a windshield wiper. Okay, this way there's only one answer. If you went all the way around the unit circle, there would be 2 answers for each of these, okay? But then it wouldn't be a function, okay? Because for every input, there can only be 1 output. So if there are 2 outputs, you no longer have a function, okay? So there is only 1 output, and we have to figure out where it is, right? So once you look at these restrictions, then there's only 1 value. Okay, inverse sine of 1/2. So we want the answer to sine to be 1/2. So here in the first quadrant, I see that I'm at angle pi over 6. Okay, what if we want inverse sine of negative 1/2? Okay, so now I want the answer to my sine function to be negative 1/2. Okay, we don't care about this guy over here in the third quadrant. All right, we don't care about 7 pi over 6 because it's not from the bottom to the top. Okay, so only this guy here in the fourth quadrant, right? And we're going to use the negative angle, so negative pi over 6. If you write this answer as 11 pi over 6, that is incorrect because those are 2 different values, right? So we need negative pi over 6. Okay, next, inverse cosine of 1/2. Okay, so back to the first quadrant. So cosine theta is equal to 1/2 when we are at pi over 3. Okay, so our answer here is pi over 3. And now arc cosine, which is equivalent to inverse cosine of negative rad 2 over 2. So we're at one of the quarter marks. Cosine is negative here in the second quadrant. So we see that the answer is 3 pi over 4. Okay, this graph here is a little bit small, but we can kind of get the idea. So talking about sine, cosine, and tangent, specifically inverse sine, inverse cosine, and inverse tangent, we'll use the first quadrant for all of those guys, right? Sine, inverse tangent are also down here since they're bottom to top. So negative pi over 2 to 0, and then continuing on 0 to pi. And then inverse cosine is here on the left since we go from 0 to pi. Okay. So let's do this a few more times. Inverse tangent of negative 1. So remember for inverse tangent is bottom to top. So we want the answer to be negative 1. So we're looking here at this angle in the fourth quadrant, right? But we know we need the negative version of it, so negative pi over 4. Okay, I'm going to come back to arctan of negative rad 3. Let's skip to inverse sine of rad 2 over 2. Okay, so again, sine is negative, So we're going to be looking here in the fourth quadrant, rad 2 over 2 again. So sine is equal to negative rad 2 over 2 when our input value is negative pi over 4. Arc cosine of negative 1. So arc cosine, so we're going 0 to pi. And then at pi, cosine is equal to negative 1, right? So the answer here is pi. Okay, and now arctan of negative rad 3. So you should have this narrowed down to one of these two angles, right? And it's not really 11 pi over 6. This is our negative pi over 6 and negative pi over 3. Okay, the ratio of sine and cosine. Okay, so let's look at negative pi over 6 first. So basically, I'm just going to check these two to see which one I want as my answer. Okay, to see which one is the correct answer. Okay, so if I look at tangent of negative pi over 6, so this is sine of negative pi over 6 over cosine. Negative pi over 6, good. So sine is negative 1/2, and cosine is rad 3 over 2. So when I multiply by the reciprocal, those 2's will cancel, and I get negative 1 over rad 3. Okay, which is not what I wanted. I want to just I just wanted negative rad 3, right, not 1 over it. Okay, so that means the other one must be correct. So let's just try it. Tangent of negative pi over 3. So again, sine over cosine. This time sine is negative rad 3 over 2, and cosine is 1/2. So this time when I multiply by the reciprocal, I end up with negative rad 3, which is what I wanted. Okay, so arctan of negative rad 3 is negative pi over 3. Okay, so let me erase some of this here on our graph. Again, you should have known, since it's arctan, you should have been looking bottom to top. Since it's negative, you knew to look here in the fourth quadrant. Okay. The question for arctan can either be what is arctan of 0, what is arctan of 1 or negative 1, and what is arctan of positive or negative rad 3, positive or negative 1 over rad 3. Okay. So if we're at pi over 4 or negative pi over 4, tangent's 1 or negative 1. Okay, at the other guys, at pi over 6, pi over 3, negative pi over 6, negative pi over 3, that's when the radicals stay, right? So it's either 1 over rad 3 or rad 3. Okay, positive or negative depending on which quadrant you're on. Okay, so this one might be a little bit, take a little bit more work, but you should narrow it down quickly and then figure out which of the two it is. Okay, moving on. All right, sine and arc sine function. So this is both the sine curve. Okay, the first one is a bit more of the graph. So normally if I asked you to graph the function, you would go from 0 to 2 pi. Here I continued it to the left a bit further. And then the restriction for sine is bottom to top. So negative pi over 2 to pi over 2. So we can see that that makes our sine curve, it is now 1 to 1 once I have this restriction. Okay, and to talk about the inverse of a function, we must start with a 1 to 1 function. Okay, that's why we have to restrict the domain to make our functions 1 to 1. Okay, here's the graph of the arc sine function. Okay, so let me put in a couple points here, so just 3 of them. Okay, so pi over 2, 1 is a graph on the sine curve, which means 1 comma pi over 2 is on the inverse. Okay, same thing, negative pi over 2 comma negative 1 is a point on the graph of the sine curve. So switch the x and y, negative 1, negative pi over 2 is on the graph of arc sine. The origin is on both of them as well. Okay, we will be talking about concavity later in the class, but if we go back to this fuller graph of the sine curve, from negative pi to 0, our graph is said to be concave up. If we poured water here, the graph could hold the water. Okay, so it's concave up, CU for concave up. From 0 to pi, if I poured water on the graph here, the water would kind of fall off the back of the function. Our graph is concave down there. Okay, and then same thing, we just look at a portion of it. It's concave up in the third quadrant and concave down in the first quadrant. When we take our function and reflect it about the line y over x, which is one way to get the graph of its inverse, okay, that concavity is going to change. So where it was concave down, the inverse function will be concave up, and vice versa. It was concave up here in the third quadrant. The graph of our inverse function is concave down. So knowing that, just knowing the concavity and knowing these 3 points on the function should be enough to get you a quick sketch of arcsine. Okay, so the 3 main trig functions that we'll be using are sine, cosine, and tangent. Okay, so we have the domain restriction, so from sine, bottom to top, negative pi over 2 to pi over 2. The range doesn't change, so that remains negative 1 to 1. Okay, and then you know that when you switch from a function to its inverse, the domain and range changes. For cosine, the restriction is like the windshield wiper, so left to right, 0 to pi. The range is the same, negative 1 to 1. And again, those switch when you talk about its inverse. There is a mistake here. So the domain for arctan, the restricted domain for tangent is going to be negative pi over 2 to pi over 2. There should have been parentheses since we don't include those values. Okay, and then same thing here with the range. There should have been parentheses. We're not including negative pi over 2 and pi over 2. Okay, good. And then this is another nice one. It gives you a good visual for where you should be looking on your unit circle. So again, bottom to top, if you're talking about sine or tangent, and windshield wiper or left to right when we're talking about inverse cosine. Okay, so some identities that are going to come up. So we're going to look at this triangle to help us. So if we are talking about inverse sine of x, okay, I think it's easier to just, if we're going to give that a name, let's call it theta. Okay, so if inverse sine of x is equal to theta, that means sine of theta is equal to x. Similarly, if inverse cosine of x is equal to, give it a name, I called it alpha, that means cosine of alpha is equal to x. Okay, so I labeled theta down here in the bottom right corner of my triangle, so this is a right triangle. Sine of theta is equal to x. So opposite must be x, hypotenuse is going to be 1. Cosine of alpha, so cosine is adjacent over hypotenuse. Okay, so alpha can be that top angle in my triangle. Okay, since alpha and theta are the 2 acute angles in a right triangle, they must add up to be 90 degrees. Okay, therefore they must add up to be pi over 2. So that is our first identity, that arc sine plus arc cosine is equal to pi over 2. Okay, next, cosine of inverse sine of x. Okay, so remember my inverse sine of x, I'm calling that theta. So I'm down here in the bottom right. And now we just want cosine of this angle. So we want to finish up our triangle. So 1 is my hypotenuse. X is the opposite side when I'm talking about theta. So the missing leg is going to be the square root of 1 minus x squared. Okay, right from Pythagorean. So cosine of this angle, cosine of theta, is going to be adjacent over hypotenuse. So the square root of 1 minus x squared over 1. Okay, moving on to the next identity. So those first 2 we did, we're on the third one now. I want sine of inverse cosine of x. So inverse cosine of x, I'm calling that alpha, and that's up here at the top of my triangle. So sine of this angle here is going to be opposite over hypotenuse. So we see that we get the square root of 1 minus x squared over 1. And now tangent of arc sine, so we're going back here to our theta, since theta is arc sine of x. So tangent of arc sine of x, tangent is opposite over adjacent, so x over the square root of 1 minus x squared. Okay, good. You don't necessarily have to have those memorized, but you should be able to figure it out by quickly drawing a triangle. Okay, so if I said to evaluate cosine of arcsine of x. Okay, give arcsine of x a name. Okay, theta is common. Okay, draw your triangle and then label what you need to in your right triangle. Okay, and then lastly, I found these graphs and I thought they were a nice visual for that first identity we had. If you're adding inverse sine of x plus inverse cosine of x, that means you're adding the y values of these two curves, and we will always get pi over 2. So you're going to come up with that orange line, right? So here at -1, we have pi plus negative pi over 2. So that equals pi over 2 when you add them together. Okay, pi over 2 and 0 obviously add to be pi over 2. Here we're at pi over 4 for both, so add them together, and we're at pi over 2 when we add them, right? So anyway, I thought that was a nice visual for that first one. Okay, good. So no lecture questions in this video. This was just a review, so I hope it was helpful. Let me know if you need more explanation on anything.